My guest today is Eric Boyd. Eric, how you doing?
Great. How are you, David?
I'm doing great. What do you do?
I run a consultancy in Chicago. Based in Chicago, we have offices in Milwaukee as well, but all I do all day, every day is Azure.
Azure Cloud Computing.
Exactly. I'm a Windows Azure MVP, and that's all I do.
What is Azure?
Good question. So Windows Azure, if I could explain it like very simply, it is a platform to host your apps. Now, much like you would do in your typical data center, you have things like VMs or servers running your apps and hosting your apps. You have other middleware and components like disks for storage. You have messaging components and stuff like that. So Windows Azure provides all of that in a box for you basically as a service that you can just use to run your apps in the cloud.
All right. Now, I have servers in my enterprise, in my organization. Mm-hmm. I could do all that stuff internally. Was there a compelling reason to move out to Windows Azure?
Sure. So there's all sorts of scenarios where you may want to move to Windows Azure. So let's say, for example, your application on-premise in your own data center, you've reached the capacity that your data center can handle.
Okay.
So you don't have any more servers or capacity, so you're going to have to buy new servers. Maybe you're out of physical space for servers, right? And so in that case, that's a good kind of tipping point for you to consider cloud platforms like Windows Azure. Maybe you just can't deal with performance. Your apps are exceeding that, or what have you. Or maybe you have a new line of business that you want to test some things out, or a startup. So Windows Azure is a good way to do that.
Okay, so you mentioned this tipping point, the idea that we had this much capacity and now we need this much capacity.
Yep.
And that's the strength of Azure, right? That's the point that, because not only do you need this much, but it's potentially you could need this much in a while.
Exactly.
But my experience is when you start to need, there's another tipping point where things get hard. You start to get really scalable applications.
Mm-hmm.
How does Azure help you with that?
Yeah. So to your point, there's a case where maybe today you just have a startup that you need one server to run, and maybe you have two for failover reasons or whatever, high availability. But maybe all of a sudden your startup takes off, and now you need a bunch. In the traditional data center, you would have to have somebody rack and stack a bunch of servers, and there's a lot of lead time for that. In Azure, you just kind of turn a dial and say, I need 100 instead of 2, and instantly, within minutes, you have your new servers and your 100 running. Now, let's say your business tapers off, or maybe it's just seasonal and you have peak demands, maybe around Christmas or something like that. Mm-hmm. Then you can also contract it back in and say, I just need 2 again.
Just turn the dial back down.
Exactly, and you get 2.
Okay, so that is a big advantage. So this idea that that dial is actually a configuration setting.
Exactly.
And it's a matter of minutes as opposed to weeks, which sometimes can happen in a big organization.
Exactly.
To scale up or scale back down again.
Yep.
Typically they don't scale back down; they just leave it up because it's
right. You have idle capacity,
and you have wasted capacity. You invested all this and you're not using it.
And so in this case, the business value is not just shutting off the servers. You're paying for the time that you're using and the resources that you're using those servers, the time you're using the servers and the resources that you use, and you pay like by the hour or by the gig or what have you. Mm-hmm. And so because of that, you have advantages to make sure that you only provision what you need. And so scaling that back actually saves you money, whereas like you were saying, traditionally on premise, we've invested the capital. There's it just sits idle, and the money's
you're not going to sell it on eBay and then buy it back again.
Exactly.
That just isn't practical.
Yeah.
So let's talk specifically about scaling up and scaling out, or just increasing your the load capabilities of your application. What kind of problems does that present, especially when we're dealing with a platform like Azure?
Yeah, so it can be challenging, especially for developers who don't think about or haven't had to think about those sorts of problems in the past, because oftentimes what we do on premise is we just buy bigger and bigger servers, right? So think about database servers. They're a prime example where we need more capacity, whether that's performance or space or whatever, and we just buy bigger servers because it doesn't scale well. Okay. And so
by bigger, you mean more CPU, more memory, more hard drive space?
Exactly. And so the cost curve, though, is exponential in that scenario and not linear. Right? As we buy bigger hardware in similar form factors, the cost grows exponentially. And so that's less than ideal in terms of scale. And so what we're really looking for is how do we scale that linearly horizontally, right? So how do we just incrementally add to that instead of having this big cost curve?
All right. So it's the one principle is that it's cheaper to buy a lot of small servers than it is to buy one big server.
Exactly.
Even though some of those small servers may equal the computing capacity of that one large one.
Exactly. So on-premise today, that's absolutely true. It would be cheaper than saying, let's just add another one of the same size versus let's throw out what we have and buy a bigger one, right? So that's what we typically do on-premise. But in Azure and in the cloud in general, you have to think about, how do I architect my app so it can scale
That's not free in terms of architecture.
Right.
You have to plan for, okay, now I've got two servers. I have to somehow coordinate usage between those. If there's data on them, I have to get the data back and forth. If there are users hitting them, I have to make sure they hit them in a way that's performant.
Yep. And so you have to start thinking about principles like principles that we should probably always have thought about, but things like statelessness on those app servers, if they're web servers or whatever, we need those to be stateless such that I can get round robin and hit any of those servers and resume where I left off on the previous one.
Okay, let's back up a little bit. This is an important principle, and I'm not sure everybody grasps it. What define state?
Sure. So let's use a web app for example.
Yeah.
Let's say I've logged in and I'm adding items to a shopping cart or something like that. That is my state. That's my current state using this web app.
Okay.
Now, that's kind of bound to a server, typically. And so if I balance over and go to it, my next request goes to a different server in the data center. So if I have multiple web servers, for example, accepting those requests, if I go to a different server, that state is gone if it's sitting on the server.
And that's merely a function of HTTP, the protocol. HTTP has amnesia. Typically, you'll request something and get a response back, and then they request something else and get a response back. And by default, request 2 remembers nothing about request 1. That's typically the way it works.
And so you hold that somewhere.
So that state information, like your shopping cart, you don't want that to disappear.
Exactly.
Just because you've navigated to another page or made a call.
So you have to think about persisting that off somewhere else, off of those compute nodes, off of the web server.
All right. So and by default, that's stored on a computer. Like if you just use the ASP.NET session object.
Yep.
Or I guess it's the HTTP session object. There's a wrapper in ASP.NET, but by default, that would be stored in the memory of the server.
Exactly.
This is the default.
Exactly.
And that's not good because of...
because you would lose it if you bounce to another server.
If you happen to the second request may or may not come to the same server.
Exactly.
Okay, all right.
And so as a result, you have to think about moving that off of those servers and storing that somewhere else. So maybe it's a distributed cache.
Okay.
So something like Windows Azure caching. So if people are familiar with Memcached, very similar model. Maybe it's storing it off in some other persistent storage mechanism like table storage, blob storage, or SQL, or something along those lines. So you have to think about that. Oftentimes what we do on premise is make the sessions sticky. So we use a feature called sticky sessions where we say make sure that after you make your first request, all subsequent requests will hit this same server, so we don't have to deal with that. That's really a hack or a workaround.
So it's not a good idea.
It's not a good idea.
Is that even possible with Windows Azure?
It's not possible with Windows Azure.
So.
Yep. So that's a good question.
All right. What else? What else do I need to think about as I'm scaling these things?
Yeah. So
up and out.
Yeah. That's often another place where we get hung up a lot of times is data. So the database doesn't really scale well horizontally, kind of naturally. And so you have to start thinking about things like partitioning databases. And there's a couple of ways to partition databases. One of the things that we commonly do on premise is partition kind of by function. So one of the examples I like to use is think about an e-commerce application. We could have one big e-commerce database, and some may, but we could have split that up and say we have customers, we have orders, we have vendors, we have a product catalog, and split that database up across multiple partitions. That's one way to think about partitioning, kind of vertical partitioning. But we also may have a situation where one of those databases is just physically too big. So whether that's the space, the physical size it takes, or whether that's the performance and throughput that we can accept with one database, it's just too big to sit in one database. And so let's take customers, for example. If we were a Facebook, we would have
massively scalable application.
Ridiculous amount of users.
I think there are more Facebook users than there are human beings
That's
on
probably
the planet.
True. Yeah. So we would have to figure out how to split that data up. And so we would have to take that data and split it up horizontally, so across sets of rows. Like, so let's take customers. We may have a customers table or a users table, and we have to figure out how to partition that up. And so we could think about things like, let's take all of the users that their first name begins with A and put it in this database, and the first name begins with B, put it in this database, and we could split it up like that, and we could have
each one of those on a different server.
Yeah, so you have to think about that sort of thing. How can we split those up? And I'm not suggesting that splitting them up by first name is the best,
right?
Because what we're really looking for is an even distribution,
right?
And so,
does Azure help us with any of this stuff?
Yeah, so with databases, for example, there's a feature in Azure called SQL federations, and federations basically lets us create a logical unit that represents a database and have multiple physical databases underneath.
Interesting.
And so it lets us take a database, let's say customers, for example. Let's say we have this one big customers database and we weren't Facebook to begin with, and then we became Facebook size. And so now we need to split this data up. And so you can issue T-SQL to say split this database on this column at this point, and it will split it.
Okay, and then your API, the code that's actually calling the database doesn't have to change. It still sees it as if it were one database. Is that right?
Sort of. So the T-SQL is similar. So there's new keywords in the T-SQL that allow you to say, when I execute this, use this node, basically. Use this federation member. So you have to add some new stuff to your T-SQL.
This is news to me. The T-SQL that ships with SQL Azure is actually slightly different than the T-SQL that I'm used to using in my on-premise application.
Yeah, so sort of. So the T-SQL generally for a SQL database is the same.
Yep.
If you're using federations, there are some new keywords that are specific to federations.
I see. Okay.
So things like split, and then with you can define which federation that you're using, which member of the federation that you're going after with your data.
Okay. All right. Interesting. Where is that configured? Is that on the portal?
It is on the portal. You can also so there's in the portal when you're working with SQL database. There's a Silverlight portal for SQL database that you can use to set up federations.
Okay. So that's on the old portal. The old Silverlight portal hasn't been ported to the new HTML5 one?
It's a SQL specific portal.
Okay.
So there's a
I'd call it a secret specific portal.
Yeah. So similar to the fact that like ACS has its own kind of portal.
Okay.
So does SQL.
I see. Okay.
Yep. And so you can do things like query SQL from this portal and stuff like that. It's almost like a web-based management studio, but it's lighter weight.
Yeah, some of that ACS stuff, by the way, has moved to the HTML5 one, but it's confusing because it's halfway there.
Yeah, it's growing over time. Like some stuff got moved this week. Reporting is now in the new portal.
Okay.
Yep.
So hopefully everything will be on one portal eventually.
It would be good.
We've talked about scaling up and scaling out, and Azure supports both, right?
Mm-hmm.
We can move to bigger servers and we can move to more servers.
We really haven't talked about scaling up, but yeah, we could.
What's better? First, what's the difference to define scaling up versus scaling out?
So scaling up, the problem with scaling up is at some point you will reach a physical maximum.
Okay.
Like you can't buy a bigger machine. Like even if that's on premise, at some point you are going to run into a spot where like I can't buy a big enough server. Like the hardware just doesn't allow it. I have to scale out. And so that's the fundamental problem with scale up.
Okay, scale up has a limit and scale out does not?
Scale out does not. You could add as many nodes as you would like.
Okay,
so now, obviously, there is some physical limit. Like a data center is only so big, but most people will never that will never be a problem.
So that tells me that scaling out is better.
Yeah.
And we already said that the hardware, if we were buying the hardware, it would be cheaper to scale out than to scale up. Is that true for the services in Azure as well?
It sort of. So the services are priced such a way that it's kind of incremental either way. But again, you reach that physical limit, and so now I wouldn't say always. So as a consultant, I wouldn't always say that scaling out is better. There may be reasons why it doesn't make sense for you to re-architect your application. Like you will never exceed the physical limits.
Okay.
And so maybe scaling up works just fine for you.
Okay.
But in Azure, you can do things like say I want a small instance or a medium instance or a large or extra large. So you have some flexibility in terms of the machine.
All right, I'll buy that. Anything else?
I don't know, man.
Any other issues with scaling out for large scale applications?
There's tons of considerations that we have to think about, when architecting these kinds of apps for scale.
Where does Azure help us specifically in this, besides this elasticity of demand to go up very quickly?
Yeah, so that's really the advantage for Azure is it is just inherently elastic. So I can easily add more. The other thing for things like storage, we talked about partitioning with SQL, but the storage services deal with that automatically for you. So, for example, if you are saving blobs, so files, media, or whatever.
So, just real quickly, the storage consists of blob storage, table storage, and the queues as well.
Yep, exactly. So it's the fundamental kind of storage components in Azure. So if you are saving a file to blob storage, so whether that's a media file, a doc, whatever that may be, when you save that to blob storage, it gets its own partition. Like a blob is a partition. And so what Windows Azure can do is say, if this partition gets hot and there's a lot of requests coming in for this partition, we can move it off to its own node behind the scenes, and you never have to think about it. So there are some advantages just in terms of scale that Windows Azure as a platform takes care of for you.
Okay. Now you can control how that scales, right, through the partition key, correct?
Yeah, so in table storage you can. So in table storage you can say, I want these records to be part of this partition, so there's a key called a partition key.
So then they'll tend to stay together on the same machine.
And then they stay in the partition. But across your table you could have multiple partitions, and so if a partition in a table gets hot, it will do the same thing and move it off to its own node for you.
Okay, and this is SQL Server really doesn't have that built into it automatically.
No, so that's what Federations tries to solve, but you have to do some manual work to move it around.
Okay, so just with the table storage tends to be more scalable out of the box.
Absolutely.
Than SQL Server.
There are different constraints with table storage, like in SQL I have relationships and I have indexes and stuff like that.
Right.
With table storage, it's really a key value pair store, and so I don't have relationships to other tables. I don't have indexes as well, other than the indexes of partition key and row key and the timestamp. And so with those, that's really all I get. So you have to think about that. It's much more scalable and elastic, but I don't have the same full features as I do in SQL.
Yeah, I've experienced this. So now this is actually a new paradigm for me. When I'm building Azure applications, I tend to step back a second and think, can I do this in table storage? Can I persist my data in table storage? Because it's more scalable, and also just the pricing is much more favorable in table storage. Maybe that I can't. Maybe I really need a relational database around that. But I always ask that question first, which is new for me. I would never think of that. Just grew up with SQL and FoxPro,
right?
Yes. Which I know you're a big fan of.
Yeah, we talked about that today. So,
and so I just think I got some data, relational database, and now I'm just hitting a speed bump. Step back. Maybe I don't need a relational database for
That's
this.
good.
It's a question to ask.
Yeah, that's good. So that's it's kind of the big NoSQL movement has been kind of driving us to ask those kinds of questions. Is, do I really need all of these relationships and what have you? And the benefit is it's a lot more scalable. It's easier for me to partition data if I don't have all those relationships. So with table storage, it's good that you ask that kind of question. And some canonical examples for me of data that works really well in table storage is things like a user profile. So the user profile is not typically something that we do a lot of searching and querying on. We usually look up a user by their ID and then we're done. So that's a great case. The other great cases for me is logging and diagnostics data. So if I want to store just a bunch of logs, table storage works really well for, because it's just massively scalable and I can just shoot out a ton of messages to it.
Okay. You're blogging about this stuff, aren't you?
I am.
Where?
ericdboyd.com, and then you can find me on Twitter as well at ericdboyd.
Eric, thanks a lot.
Thanks, David. I love hanging out at conferences like this with all of my friends in technology.